Welcome, Jordan. All right, we're on. We're on, guys. Last chance to review Chapter 2. I did receive a series of questions, and you certainly can add to that list anytime. I am going to start with the questions that I got from email, and the first one is number 27. So 27, I've gone through this one before, but it might have been with the other class. You know, you can never be quite sure of this. But anyway, here it is. The sine of pi over 6 plus delta x minus 1/2 all over delta x. What's the limit of that as delta x approaches 0? So if you look in your books, I mean, I used a trig identity here, which let's see. Looking in my book here, on the second, you know, if you open up your front cover and look at the second page, in the bottom left corner, do you see where it says sum and difference formulas? Sum and difference formulas. Well, look at the top one. The sine of u plus and minus v. Okay? So that's the one I used. So we have here the sine of the sum of two angles, pi over 6 plus delta x. And that basically says take the sine of the first times the cosine of the second plus the cosine of the first times the sine of the second. And that's what I did right here. So take the sine of the first, pi over 6, times the cosine of the second, delta x, plus the cosine of the first, pi over 6, times the sine of the second, delta x. And then we still have this minus 1/2 here on the end. All right, now we can start playing around. We know what the sine of 30 degrees is. That's 1/2. And the cosine of delta x, as delta x approaches 0, what's the cosine of 0? 1. So I made those two substitutions. Plus the cosine of pi over 6, which is the square root of 3 over 2, times the sine of delta x. I can't substitute that because what's the sine of 0? I guess I could have. But anyway, let's just leave it in there. The sine of delta x, and then minus 1/2. Well, 1/2 times 1 is 1/2, and then adding that to the negative 1/2 wipes those two out, leaving you with the square root of 3 over 2 times the sine of x over delta x. And what I have in the box there, do you recognize? That's one of those 3 special limits. That's one of these guys. There it is right there. The limit as x approaches 0 is 1. So I substituted a 1 there, and you can finish it up then. Square root of 3 over 2 times 1 equals square root 3 over 2. So that was number 27. Number 28. Okay, number 28. Cosine of pi plus, so this is another one of those where you have a cosine of a sum of an angle. And I used another formula from the second page of your book there, the cosine of u plus v. The only difference is you can't tell it there, but you notice how the top sign is minus? So cosine of the first plus the cosine of the second minus the sine of the first times the sine of the second. And that's what I used right here. Cosine of the first, pi, times cosine of the second, pi x, minus sine of the first, pi, times sine of the second, delta x. And then this plus 1 is on the end, divided by delta x. All right. What's the limit as delta x approaches 0? Cosine of pi, negative 1. cosine of delta x, we'll just leave that for the moment, minus the sine of pi, 0, times the sine of delta x. Okay, what's 0 times the sine of delta x? Nothing. But the thing is, okay, let me just hang on here. Yeah, so then there's a plus 1. And then you factor out a negative 1 from the top, and what you have is cosine minus 1. So this part, the cosine minus 1 over delta x, that's this guy right here. Well, it's the opposite. Hang on. What did I, let me just take a look. 28, 1 minus cosine. And is that, how does that compare? Yeah. So the only difference is, let me go back here again. 28. So I should have left it the way it was. Oh, well, I wrote that last step wrong. I mean, this part, all right, this part right here is that identity, isn't it? That's right from this guy right here. Well, I guess I have it backwards. Sorry, I'm having trouble with my, this is the identity right here. Okay, and that's equal to 0. And what's negative 1 times 0? 0. So anyway, that was one of those based on trig identities. Again, one of the reasons, I don't know why I'm doing this, but I'm going to let you use that page from your book. Okay, that was 28. Next request, number 34. Okay, so let's see what we got here. Yeah, there it is. All right, number 34. So let's work on this. So, and by the way, the directions, what are the directions for 34? Use a graphing utility to estimate the limit. All right. So use a table. Find the, here's what I'm going to do. Find the limit by analytic methods. You know, this is where you actually use algebra, and this is what I would test you on. Okay, so let's write this thing out in a little different way. So limit x approaches 0, 1 over x plus 4 minus 1/4 all over x. So that's the bad news about the way the book will sometimes write a problem. It's a little bit hidden. This is what we're really doing. Well, we can't substitute because of the denominator, so we have no choice but to get that top thing together. All right, so let me change colors here. So what we're going to do is we need a common denominator of what? X plus 4 times 4. So this one is short of 4, so we'll multiply top and bottom by that. This one is short an x plus 4, so we'll multiply top and bottom by that. Okay, so now we're going to have a common denominator. So now so they're both going to have the common denominator 4 times x plus 4. And the first fraction will have a 4 on the top. And the second fraction will have an x plus 4. And then way on the bottom here, we still have this guy. By the way, the parentheses I put around x plus 4 are really important. Because if you don't put, you'll lose the, see, you're going to wind up, you got to subtract x and 4. And without the parentheses, you might forget to subtract the 4. All right, so over x is the same as over x over 1. And now we can do an invert and multiply. So now we can do limit as x approaches 0, 4 minus, and let's do that top. What is 4 minus x? What's 4 minus 4? Gone. And then we have to subtract the x, correct? So what we get on the top is minus x. And on the bottom, we get this 4 times x plus 4. And then you invert and multiply for this thing. Oh, and the x's cancel. And x was what was causing the problem. So x's cancel. You get a 1 on the top. So now what's the limit as x approaches 0 of negative 1 over 4 times x plus 4? Now you can substitute it, x equals 0, and you get negative 1/16. Any follow-up questions on that one? So what was that number? That was number 34. Okay, the next one we're going to look at is 41. So 41 is in this group on the assignment where they say, find the limit if it exists. If it does not exist, explain why. So number 41. All right, so we can't substitute in a 4, but remember, this is x is approaching 4 from the left. So what do you want to be? Yeah. So anyway, I can multiply top and bottom by the conjugate of the top. I somehow got to get x's to do something, so I've got to get rid of that square root on the x. So I multiply top and bottom by the conjugate. So right here, x square root of x plus 2, square root of x plus 2. What that gives me now is the limit, and on top you get the first number squared, x, minus the second number squared, 4. And lo and behold, look at the x minus 4 will cancel with the x minus 4 on the bottom, and you get the limit as x approaches 4 from the left of this 1 over the square root of x plus 2. So when you plug in a 4, what's the square root of 4? 2. 2 plus 2 is 4. Limit, 1/4. Question? Next one that was requested was number 45. Okay. So what's the limit of f of x as x approaches 2? And you've got yourself a piecewise function, 2 pieces. Can you substitute? You sure can on the top. 2 minus 2 is 0. 0 squared is 0. So the limit from there, and on the bottom one, as x approaches 2, 0. Oh. So what's the limit as x approaches 2? They agree, both the left and the right hand limits, so we're done. It's 0. Anybody? Okay, let's take a look at 46. Well, you can see All right, what's the problem? This is another piecewise, and what's the problem here? Can you substitute in a 1? You can on the top. 1 minus 1 is 0, and the square root of 0 is 0. So that one comes out to 0. How about the right side? Can you plug in a 1? Yeah. So the left and the right-hand limits do not agree, and you can see that when those limits don't agree, it does not exist. So you could just say here, explain why the left and the right-hand limits do not agree. I'm trying to keep my eyes open for questions, both email, text messages, and in the chat window, and I'm not seeing anything. Okay, let's go to the last one that I was requested for this group, and that's number 62. Okay, so yeah, so here we go with number 62. In exercises 57 to 64, describe which intervals on which the function is continuous. All right, 62 is, this one right here. So h of x equals -2 times the natural log of 5 minus x. So there is, you can take the natural log of just about anything. You can't, however, you can't take the natural log of a negative, but there's no danger of that, right? Because we're taking the absolute value of it. So in other words, e to a power, no matter what you do with the power, you cannot make that number negative. So that would be a problem, but that's taken care of with the absolute value sign. But there is one thing that's not taken care of. You cannot take the natural log of 0. Again, there's no power you can put on e for which the answer will be 0. So we can't have a 0 in there, and x would make that a 0. I'm sorry, 5 would make that a 0. If you plugged in a 5 for x, can't do it. So therefore, everything's okay up to 5. Everything's okay after 5, but you can't have 5. So basically, you've got to break that into, all right, well, it's okay. Everything's okay, negative infinity up to 5. Everything's okay from 5 to infinity, but there's just that gap where it can't be 5. So you would write down the 2 intervals for which it can be. Okay, now I also got 1, 2, 3, 4, 5. I got 6 requests from the first class, but before I go to those, do you have any? Are there any questions that somebody wants to bring up? $55 and $56. All right, will do. So here's 55. Making a function continuous. So right now, c is a constant which we don't know. And they're saying to you, what does c have to be so that these two parts of this piecewise function connect, and therefore it would be completely continuous? Well, the answer is, let's find out. What would it take to make x plus 3 equal to cx plus 6? So we just literally say x plus 3 equals cx plus 6. We can then solve for c. C is a -1/2. Yeah, this 2 just means 2 is what? 2 is, because one leaves off at 2 and the other leaves off at 2, these both have to be the same when x equals 2. When x equals 2, the top one is 5. what happens on the bottom when x is 2? 2 times negative 1/2 is negative 1, and negative 1 plus 6 is 5. Yep, they're together. So answer to the question, when c equals negative 1/2, this two-piece function becomes connected and therefore continuous. '56. Okay. So 56 is the same thing, same kind of a deal. You've got this piecewise function. It's a little more complicated though, because this time x plus 1 is only true when you're between 1 and 3. And this other one, x squared plus bx plus c, is only true when the absolute value of x minus 2 is greater than or equal to 1. So the first thing I did is I tried to make more sense out of this absolute value of x minus 2 is greater than 1. So look down to the bottom left here. So I don't know what you remember about solving absolute value inequalities, but you really have to break them into two pieces. You have to drop the absolute value sign, and on the other part, you have to change the sign on the non-absolute value side, and you have to reverse the inequality symbol. And the bottom line is, what that's telling you is, this second equation is true when x is greater than or equal to 3, and when x is less than or equal to 1, which is basically on these, on those two borders, 1 and 3. So the key points here are 1 and 3. All right. Did everybody see that? So when x is 1, the question is, does it connect? And when x is 3, does it connect with this other thing? Well, we can find out. When x is 1, I'm sorry. Yeah, when x is 1, the answer is 2. Let's see. What was I? Hang on. What was I doing here? Oh, yeah. So I just said, yeah, I was checking out. I was doing the 1. So the question is, when this thing turns out to 1, x has to be 0, right? Hang on. Something goofy there. Let me just see. What was I thinking? Yeah. When this is equal to 1, then x is 0. And when this is equal to 1, if you plug in an x equals 0 here, what happens? 0 plus 0 plus c equals 1. Oh, c is 1. So we just found out that c equals 1 is that's one of the things we just found out. C has to equal 1. Okay, but now the other point is 3. And when will x squared plus bx plus c equal 3? Well, that thing will equal 3 when x equals 2, the top one, because 2 plus 1 is 3. And if x equals 2, plug it in. 2 squared is 4, plus 2 times b times 2, plus c equals 3. But we know c is 1. So we plug that in, and we find out way down here in the bottom. So basically, they asked you, what b and c do you need to make that true? And we were able to figure it out. When c is 1 and b is negative 1. Then these two functions would form a continuous. Okay. Okay. So I still have these other ones from the other class to look at, but are there other questions? All right. Well, from the other class, they requested number 61. Oh yeah. Well, okay. We may have talked about that in this class. So, but number 61 says this guy right here. When is that continuous? And we've got that weird exponent of the greatest integer of x divided by 4. So you already know that if x is anything from, let's say, 1 to 1.9, the greatest integer of any number from 1 to 1.9 is 1. So we know that's going to come out the same for that whole part. Okay, so that's connected. But as soon as we go to 2, we have a jump. And everything's okay. It's same 2, 2, 2.3, 2.6, 2.8, 2.9. But as soon as you jump to 3, we have another jump. So we looked at this thing. Here it is. I mean, basically, this thing is, so the question is, this is a discontinuous function. It's got jumps all over the place. But so if you were asked to put down what intervals are continuous, you could say, all right, it's continuous from 0 up to 1. Oh, and then it's continuous from 1 to 2. And then it's continuous from 2 to 3. And I mean, there's all kinds of these little continuous things. And that I express this way. So if you take k to be any integer, I mean, sure, from 1 to the next number, yeah, that's cool. It's continuous. Actually, that left bar there should be a bracket. So it includes the left side, but not the right. Because as soon as you get to the right, it zips to the next portion. So somebody wrote to me in the other class, said, how in the world is that continuous? It is not continuous. And you can see that clearly. But they said, what are the intervals of continuity? Oh yeah, we can break it up into all these little continuous segments, and that's what this is saying. So that's 61. All right. Follow-ups. Let's take a look at the next one is 48. Okay, that's 47. Where is 48? I guess we'll just do that one by looking at it. Where's 48? Okay. So we've got this function up here. Limit when s approaches 2 of f of s. And f of s is another piecewise function. Okay? So what's going on in that piecewise function? When you plug in a 2, what do you get on the top? I'm sorry, when you plug in a negative 2. A negative 2 squared is 4, but then that negative has to be applied, so that's negative 4 plus 8, which is 4, and 4 minus 2 is 2. So we get 2 on the top. What happens when you plug in a negative 2 on the bottom? Negative 2 squared is 4. 4 minus 8 is negative 4. Negative 4 plus 6 is 2. It's continuous because the left and the right sides work out. Okay, I'm checking. I got a question. Can you explain? So you still don't get the greatest integer of x. All right. Well, let's see. Let's just find a clear spot here. So what that literally means is when I pick a value for x, give me back the greatest integer less than or equal to the number. So if I ask you to find f of 1, what is the greatest integer less than or equal to 1? And the answer is 1. Okay, what's f of 1.3? What's the greatest integer you can think of that's less than or equal to 1.3? Answer, 1. So what's going on here is for all these different one and a fraction numbers, you're going to keep getting a 1. The greatest integer. Give me back the greatest integer. You know what integers are. Those thermometer numbers. Give me back the greatest integer that's less than or equal to the number I gave you. And then as soon as you go to like 2, well now, what's the greatest integer less than or equal to that? 2. Be careful when you're asked to find the greatest integer of a negative 1.3. What's the greatest integer of that? Don't just say negative 1. It's actually negative 2, right? Negative 2 is the biggest integer that's less than negative, so less than negative 1.3. So I don't know if that helps, but that's what the greatest integer function does. And then what happens is you get this step ladder. Here, let me. It looks like this. So what's the greatest integer less than or equal to 0.5? 0. And so where's the height? 0. 0.9. 0. But as soon as I ask you the greatest integer of 1, it hops up to 1. So you wind up with this kind of a map for the greatest integer. So let me just check my messages again. So anyway, I don't know. Hopefully that's enough for you who sent me that text message. Now, what were we doing? Oh, another one I got requested was number 3. Okay, so number 3, let's look at the book for this. Number 3. Whoop. Okay, so number 3 was one of those table problems. And it says complete the table. Yeah, I mean, this would require a graphing calculator, and I'm not going to put that thing on the test. But nevertheless, do you see what they're trying to get you to do? They're trying to get you to find out what happens when you get to 3. And you can't get to 3 because 3 would create a 0 on the top and a 0 on the bottom. 3 minus 3 is 0. 9 minus 21 is what? Negative 12. And so the bottom is 0. So 0 over 0, that's garbage. But you can factor that thing, right? So you could go in there and say, hey, that's x minus 3 times x plus 4. And then you could cancel the x plus 3s, I'm sorry, the x minus 3s. And you wind up with, on the bottom, what was it again? Gosh, x minus 3, x plus 4. The x minus 3s cancel. And now when you plug in a 3 on the bottom, you can actually do it. Here, let me do it off to the side. Let me grab this. So even though they had you do it with a table, you can do that just as well using the algebra, the techniques I've taught you. And so we will do that here. So, all right, so we can rewrite this and say the limit as x approaches 3 of x minus 3. And then if you factor this, you can see it's x minus 4, x minus 3. And now can you substitute? Yeah, on top the 1, and on the bottom you get a negative 1. So that's more important. That would be a more important version of number 3 than the one the book gave you. So I'm not going to give you a calculator table problem. I want you to be able to use algebra to solve. All right, so that's okay. Then I was asked about number 6. Let's take a look at number 6. So this is a possibility on the test. So I give you a graph and I say, can you just visually look at this graph and tell me what's the limit of that function as x approaches 0? So you're looking at two things now. You're looking at what's the limit as we approach 0 from that side, and what's the limit as we approach 0 from the right side. Well, as we approach it from the left, it's negative infinity. As we approach it from the right, it's positive infinity. Oh boy, those don't agree. Does not exist. And then part B, what's the limit of this graph you see up here as t approaches negative 1? So now this is your target point. And you see how the left and the right hand limits perfectly agree. And where do they arrive? At the height of 0. So, I mean, that's important that you can do a visual limit like that. If you have the graph, you should be able to handle a problem like that. And then the last one I got was number 88. There's 87. Okay, let's talk about number 88. So what's the limit of 12e to the negative 2 over x as x approaches 0 from the left? So as x approaches 0 from the left, it's going to be an incredibly tiny negative number from the left, a tiny negative. What's negative 2 over a tiny negative? Well, negative divided by negative is positive, and negative 2 divided by a real tiny number is infinity. So that'd be a positive infinity. Now, what's e to the infinity power? Infinity. And what's 12 times infinity? Yeah, we're stuck on infinity now. So that limit would have to be infinity. Yeah, Claire, that is correct. On the test, you do not get to use calculators. Are there any? What's next? I'm going to check my messages. It's always hard to keep my eyes in about 4 different places here. Okay, it doesn't look like there are any waiting for me. What's the email situation? 2 new ones from WLC. No, none of those are for this class. Okay. Anybody that has any questions? Okay, I'm going to call it quits. Don't forget, we do have this. We have a test tomorrow. I'll see you then.